All right, so the home plate for tonight, it says identify the GCF and LCM. It's, for number 1 is negative 144x squared y to the 5th, comma, and the other number is negative 36x cubed y. Number 2 is negative 84, comma, and 60. Number 3 is 60a to the 5th, b to the 8th, comma, and the second number is negative 90a cubed, b to the 10th. And the number 4 is 400x squared y to the 9th, comma, and negative 120x to the 9th, y to the 5th. And in addition to that, you already know that you have page, what is the page? 520 only. So only that for home plate for tonight. What? It sounds like it's less, right? Okay.
How many problems are there on test 20?
I don't know. I don't think you will have a problem with them.
Oh my God! How many?
So with that said, is everybody done? Okay, let's move on.
Do you think you could do those like when you were in kinder?
Something like that. All right, here we go. So, get a Cornell note ready, please. Entitle it Identifying GCF and LCM. You do need a Fair model. So, our objective for today, I can identify the greatest common factor and the least common multiple of two numbers. Let's read it together. 1, 2, 3. I can identify the greatest common factor and least common multiple of two numbers. Read it again. 1, 2, 3. Okay, how about Isaac? Can you repeat that for us, please?
Can you repeat it?
I can identify the greatest common factor and least common multiple of two numbers.
Thank you. How about Andrea?
Ooh. I can identify the greatest common factor and the least common multiple of two numbers.
All right. So today we're revisiting greatest common factor and least common multiple. That you should know how to do. The only thing whenever I teach this, I teach it together. When your teachers taught you in the past, they did it 2 separate lessons and 2 separate chapters, I believe, or something like that. Today we're going to use a tool for this. And the tool that we're going to use today in order to find the GCF and LCM is the Venn diagram. Who remembers Venn diagrams? Or who uses Venn diagrams right now? So, do they use them in language arts for you guys yet? No?
We don't do anything. I'm just kidding.
So we're going to use them here today. So before I get started with the lesson, let me just intro Venn diagrams, but I'm going to use it using a question. The question for today would be, what do I have in common with Michael Jordan?
Oh my God, it's like, not funny, guys, not funny.
All right, so I'm going to get a Venn diagram going. Here's Michael Jordan's circle. This is my circle.
Compare me and him?
Yes, we are comparing me and him. All right, here we go. So, Michael Jordan is tall, and I'm not that tall. Okay. Michael Jordan is a professional basketball player. I'm a teacher. Michael Jordan is rich. I'm not rich. However, we do have one thing in common, and this is one of the things that I started following him for. I saw him in an interview, and he said that one of his favorite subjects is mathematics. That was his favorite subject in school. Yes. And that's why, I don't know if you guys notice, they still have a lot of name brands after him and a lot of advertisement using him because he's really good with numbers, and when it came down to making contracts, getting numbers down by the dollar, he's still getting paid royalties for a bunch of stuff that he started back in the 80s. Whereas, if you do a research, there's a lot of professional athletes that after they finish their careers playing whatever sport, they end up bankrupt within the first 5 years of retirement. So do a research and see what you find. But yeah, he went to school, he got his degree, he finished, and he also loves mathematics. That's his favorite subject. So that's one of the things that made me follow him. So in regards to the Venn diagram, look up, please. Here's my Venn diagram. Here's his circle, here's my circle. But what did we have in common, both of us? Favorite subject, math. Did I have to write favorite subject, math 2 times in here? No, because both circles overlap and we only write it once instead of twice. Are we there? And that's the same process that we're going to use today, but with numbers, using Venn diagrams with numbers. I just wanted to introduce it like this. Yeah.
In the common little circle thing,
Yeah.
I thought you were going to put, like, ball master. What?
Ball master.
Or, like, you guys are, like, really good ball players.
No, no, I'm way, no.
Both of you do the Air Jordan. I think you can do it too.
Bad, no. All right, here we go. Wow, be nice. All right, here we go. I know, you bullies. I'm going to go and tell Mr. Sanchez. All right, here we go. So with that said, so today we're going to use the Venn diagram. So on your Frayer model, write this down. Factors. What are factors? Factors are 2 or more numbers that are multiplying. Factors are 2 or more numbers that are multiplying. Factors are 2 or more numbers that are multiplying. Factors are 2 or more numbers that are multiplying. Factors are 2 or more numbers that are multiplying. Factors are 2 or more numbers that are multiplying. Factors are 2 or more numbers that are multiplying. Example: 2 times 5, 2 times 3 times 7, 3 times 5 times 11, 2 times 2 times 3 times 3 times 5. Now let me ask a question. According to the definition, it says 2 or more numbers that are multiplying. Could it be negative numbers?
Yeah.
Yes. Could it be fractions and decimals?
No.
Yes, because fractions and decimals are numbers.
Wow.
2 or more numbers that are multiplying.
You just said, like, when we're talking about, like...
That was prime numbers. Right now we're talking about factors. Okay. So, non-examples. Write these down. 2 plus 5, 2 plus 3 plus 7, 3 plus 5 minus 11, 2 divided by 2 minus 3 plus 3 plus 5. Copy that, please. All right, here we go. So once again, factors are 2 or more numbers that are what? Multiplying. So, talk it over with your neighbor. Why are these not factors? So therefore, the most important thing to remember, 2 or more, and they are what? Multiplying. Fairly simple? All right. Steps, write these down, please. Only 4.
Yeah.
It says, step 1, write the first 5 prime numbers at the top of my page. Step 2, find the prime factors of each number. In parentheses, start with a prime number. Step 3, use a Venn diagram to organize all prime factors. And step 4, identify GCF and LCM. Copy that, please.
I finished.
All right, so at the top on step 1, it says, write the first 5 prime numbers. So that we know which ones they are, it's 2, 3, 5, 7, and 11. So anytime that we're going to be finding prime factorization, from this point forward at the top of your page, always write those first 5 numbers. Okay. So step 1 says, write your first 5 prime at the top of my page. There it is. Step 2, find the prime factors of each number. Start with a prime number. That means starting with one of these. And from there, use the Venn diagram to organize all prime factors and identify GCF and LCM. Thank you, Lauren. So, everybody got it? All right, so let's move on. So, example 1. Copy this, please. Let me zoom in. It says, example 1. What is the greatest common factor and least common multiple of 24 and 36? Copy that. So, look up, please. It says, what is the greatest common factor and least common multiple of 24 and 36? So, I'm going to take you guys back to elementary. This was, I think, in 3rd grade when your teacher said, okay, kids, today we're going to factor, but we're going to use factor trees. Yay! Remember that? So, but now according to our process, the first thing we needed to do is write the first 5 prime. There they are. Are we there? I want you to write also 24 and 36 side by side, but leave a space here in between, at least about an inch or so on your paper. So 24 and 36. So we're going to find the prime factors, and we're going to use a factor tree. However, we're going to start our factor tree for 24. Here it goes. Draw 2 arrows. The first number has to be a prime number. It specifically has to be one of these 5 prime numbers. Which one shall we start with?
2.
Okay, I'll start with 2 for this one, but it could be 3. So this is 2 times 12, yes? Circle the 2. That's a prime number because we can't do anything with it, and that branch is going to stop growing at that point. Right? The 12 becomes what? 6 and 2, but remember we start with the prime number, so it's 2 times 6. Circle the 2. It's a prime. That branch. What's that? It could have been 3 and 4, yes. So the next one is 2 times 3. So therefore, circle both, and they stop at that point because those branches are prime numbers, right? So therefore, these are prime numbers. Is that correct? But what did we say? These are called prime factors. But why are they called prime factors? Because check this out. The word factors implies to do what? We just covered that. Factors multiply. Factors implies to multiply, right? So watch. What is 2 times 2? Times 2 times 3. It should give us the original number.
Oh my.
That's why they're called prime factors.
Wow. No, we didn't.
You learned this in elementary, but some teachers don't break down terms. So that's why I'm trying to connect here to, 1 plus 1. Let's do the next one. Here we go. Look up. So 36. Open up your branches. This one divide by 2. This is 2 times 18. Circle your 2. The 18 is 2 times 9. So that's circle your 2. And the 9 is 3 times 3. And circle both. And once again, what are these called? Prime factors. Why? Because they're prime numbers, but if we multiply them, it should give us what? 36. 2 times 2 is 4 times 3. That's 12 times 3, 36. Are we there so far? Next, let's draw a Venn diagram down here. Nice and straight like mine. Thank you. Wow. Very nice for a difference.
I'm always nice.
Wow. Copy this, please. On this one is going to correspond to the 24, and this one is going to correspond to the number 36. So it's basically kind of like what I did at the beginning of the lesson, right? This could have been Michael Jordan. This could have been me, right? And this is what we have in common. But now we're using numbers. Are we there so far? So now, before we get started filling this out, let's write our prime factors here. 2 times 2 times 2 times 3. Are they prime factors? Yes, they're prime numbers, factors, because they're multiplying. Let me write the other ones over here. This is 2 times 2 times 3 times 3. Are we there so far? All right, so now let's start filling in our Venn diagram. We want to find out what we have in common. So let's see. Underline the 2. Is there a 2 on the other number? Yes, so underline the other 2 and write it only once. Is that correct? All right. Underline another 2. Is there another 2 on the other side? Yes, so underline it and you write it again only once. Is there another 2 on the other side? Since I already underlined it, I'm going to box it so that I know that I'm going to leave that by itself. From there, is there a 3 on the other side? Yes, underline the 3 and write it in here. And since we don't have any more numbers on this side and the 3's by itself over here, I'm going to box this 3. There it is. So what was left for this number? 2 times. And what was left on this number? 3. Okay. I'll stop right there. Does everybody see how we only wrote this only once? Yeah, because some of you, in your brain, some of you still don't understand, if I had a 2 here and I had a 2 here, how come we only wrote it once? Now, pen down, and I'm going to show you with some animation. as to why this is only written once. Here it goes. So I have my Venn for the 24. And what are my factors? 2 times 2 times 2 times 3. Now I have my Venn for the 36, and my factors are 2 times 2 times 3 times 3. Are we there? But if we were to overlap these, we can actually see which factors are overlapping and how they only appear once in the center. Does everybody see that? That's why we only write it in there once. Everybody with me? Was that pretty cool or what? So with that said, now we can identify two pieces of information only using this one tool. What did we have in common right here? The 2 times 2 times 3. Well, with numbers, this is what we call the greatest common factor. GCF. So what is our GCF? Which is 12. So write that in there, please. GCF is 12. Now check this out. To find the LCM, instead of going down like this, we go like this. LCM. Let's see. We know that the center is what? 12. So what is 2 times 3? What? So I'm multiplying 2 times 3. What is 2 times 3? Times 12.
What? 72.
72 is my LCM. Now, if you don't see it like this, then let's go one number at a time. What is 2 times 2? 4. Times 2, 8. Times 3, 24. Times 3, 72. Yeah, you can multiply them all, or you can do this next trick that I'm going to show you. Look up, please. Watch. What was left over on this side? 2. If I multiply that times the opposite number, what is 2 times 36?
70. Oh my God.
What's left over here? 3. So what is 24 times 3? 72.
Oh my God.
And that will always work. That will always work. So therefore, let me go backtrack the steps. Step 1, factor tree for 24, factor tree for 36. We find our prime factors. We identify which ones are common. They go in the center only once at a time. And then at the end, we get our GCF and LCM. Yes? See if you can do this next one by yourself. Example number 2, you don't have to copy the words down anymore. Just copy the numbers, please. Don't forget to write your first 5 primes somewhere on the side. And it's 12 and 18. 12 and 18.
Can we do it?
Yes.
Okay.
Okay, here goes 12. My factor tree, I started with 2 times 6. Circle the 2. The 6 became 2 times 3. Circle the 2 and the 3. So those are my prime factors. 18. I started with 2. 2 times 9. And the 9 became 3 times 3. Some of you might have started with a different prime number, right? Okay. So now from there, I'm going to get my Venn diagrams. So I'm going to write my prime factors. For this one was 2 times 2 times 3. For this one was 2 times 3 times 3. Therefore, what is this? Do I have a 2 on this side? Yes, I write it in here. Do I have another 2? No, I box that. Do I have a 3? Yes. And this one's left over, so I box the 3. So what's left over here? And what is left over here? 3. So therefore, GCF is 6 and LCM is
39. Oh my God.
36. 2 times 2 is 4. 4 times 3 is 12. Times 3, that's 36. Or 2 times 18 is 36. or 3 times 12, that's 36. Are we there so far? So now, from this point forward, look up please. Couldn't I have started here, look up, the 12 started with a 3? How about the 18? Couldn't I have started with a 3? So from now on, when I ask you to factor, I want you to look at the first 5 prime, but start with the biggest prime number that can divide in there.
Oh, wow.
So look, for example, here I started with the smallest prime number, which was a 2. But I could have started with what? The 3. So I can, you know, go a little bit faster. Are we there? Do this next one by yourself. Example 3. Okay, copy that. Example 3, 45 and 36. See if you can go a little bit faster now. Find me the prime factors. Do the prime factorization. Draw your Venns. Find me GCF and LCM. Go. Okay, check with me, see what they got. In the meantime, here goes my factors. The highest factor out of these 5 for 45 is 5, right? 5 times 9, I circled the 5. 9 is 3 times 3. And those are my prime factors. For 36, I can start with which number? 3. 3 times 12, circle the 3. And this one is 3 times 4. And this one is 2 times 2. Those are my prime factors. So, I'm going to get my Venn diagrams going. And my factors, this one was 5 times 3 times 3. This one is 3 times 3 times 2 times 2. So let's see. Do I have a 5 on that side? No, I boxed it. Do I have a 3? Yes, I underline it. There it is. Times. Do I have another 3? Yes, I underline it. And do I have anything left on this side? No. How about on this side? Yes, 2 times 2. So therefore, my GCF is 9. My LCM is, now look at this one. Pens down really quick. What's left here? Nothing, right? Oh yeah, the 5, my bad, the 5. 5. So what is 5 times 36?
180.
180. Or you could have done 4 times 45, should be what? 180, or all the way across. Hands if you got that? Alright. So now that we're done with the easy stuff, let's move on to some algebra. Here we go. Copy this down, example 4. Yeah. Look up, please. If there's nothing left on one of the circles, remember, it cannot be 0 because 0 will make all of this what? 0. So it has to be a what?
1.
A 1. So make sure you don't leave it blank at the end. Okay? You just put 1. Let's go to the next one, example 4. Copy this. Example 4. Here we go. You don't have to copy the words. Just copy 60x cubed, leave a space, and 72x to the 5th. Alright, so let's get started. Start with a 60. Which of these prime numbers can we start with?
5.
5 times 12. Circle the 5. The 12, start with what? 3. 3 times 4. And the 4 becomes 2 times 2. So my prime factors are 5 times 3 times 2 times 2. Are we there so far? However, now we have variables, right? So the x cubed can be broken down into x times x times x.
Oh my god, it's so much easier than I thought. Oh my god.
It is.
I thought it was gonna like, you have to break down x.
Let's look at this one now. 72. Which one of these can we start with? 3. 3 times 24. This one is 3 times 8. This one is 2 times 4. And this one is 2 times 2. So my prime factors are 3 times 3 times 2 times 2 times 2. Are we there so far? But the x to the 5th, we have to write it out as x times x times x times x times x in factored form. So far so good? Alright, let's draw our Venn diagram. 1 potato, 2 potatoes. There it is. This Venn diagram corresponds to 60x cubed, and this one corresponds to 72x to the 5th. Be nice. Here we go. Is there a 5 on the other side?
No.
No. Box that, because that's by itself. Is there a 3?
Yes.
Yeah, underline a 3 and write it in here. 3 times. Is there a 2? Yes, right there, so you write it once. Is there another 2? Yes, underline another 2. And we're done with the numbers. So what was left on this side? 5. What was left on this one? 3 and 1, 2. So you write times 3 times 2, and this one times. All right. So now let's go with the variables. Is there a x on the other side?
Yes.
Is there 2 x's on the other side?
Yes.
Is there 3 x's on the other side?
Yes.
Yeah, so underline 3 x's and 3 x's, so we write x times x times x. How many x's are left over here? None. How about on this side? 2, so we write x times x. All right, so let's see. GCF. What's our GCF? What is 3 times 2 times 2? 12. And what is x times x times x? X cubed. So my GCF is 12x cubed. Let's find our LCM. Let's see. Do you want to multiply the 5 times the other side, or do you want to multiply all of these, or what do you want to do? All of these? Okay. 5 times 3 times 2 times 2 times 2 times 3, 360. All right. And what is x times x times x times x times x? X to the 5th. Or we could use a shortcut. What was 5 times 72? 360 x to the 5th. Or 6x squared times 60x cubed. What is 6 times 6? 36. What is x squared times x cubed? X to the 5th. All right, let's do another one. Do this one by yourself. See how you do. Copy this one. Example 5.
I've already used 3 papers. Oh my God.
Here it is. Negative 90 a to the 5th and negative 72 a to the 2nd. Now check this out. I'm going to help you with the first part. I'm going to rewrite this negative 1 times 90 and negative 1 times 72. So like that you can focus on the positives, right?
Yeah.
But at the end you include the negative 1 at the end. Everybody see what I did? Isn't negative 90 the same as negative 1 times 90?
Yeah.
Isn't negative 72 the same as negative 1 times 72?
Yeah.
So, no?
I don't get why. I don't get it.
Okay, then that's fine. Then I'll leave it as a negative and work it out by yourself. Here we go. Negative 90 a to the 5th.
We would work out the positive and then at the end multiply by negative?
Yeah.
Okay, so can we do that?
Yeah.
It's confusing. Oh my God.
Copy that, please. All right, here it goes. I'm going to rewrite this one as negative 1 times 90 a to the 5th, negative 1 times 72 a to the 2nd, and I'm going to focus on the positives. This one can be divided by 5. 5 times 18. The 18 is 3 times 6, and the 6 is 2 times 3. All right? So my factors are 5 times 3 times 2 times 3. This one. Oh, and I'm going to a times a times a times a times a. Oh, and I forgot the negative 1. Sorry. There it is. This one. This is 3 times 24, 3 times 8, 2 times 4, 2 times 2. My factors are 3 times 3 times 2 times 2 times 2 times negative 1, and a times a. Are we there so far? My Venn diagram. So this one corresponds to negative 90 a to the 5th, and this one is negative 72 a to the 2nd. So therefore, what is the same here and here? We have 2 3s, and 1 2. So, and the negative 1. This is negative 1 times 3 times 2 times 3 times 3, 3, and 2. So what was left over here? 2 times 2, and on this side, 5. Okay. So how many A's did both of them have in common? 2, A times A, and this one has A times A times A. My GCF is negative 1 times 3 times 3, that's 9 times 2, that's 18, negative 18A squared. Hands if you got that. Okay. LCM, what is 5 times negative 72? That's negative 360. And what is A cubed times A squared? A to the 5th. Have a good one, guys. Enjoy your home play. If I don't see you tutoring, I'll see you guys tamales. Okay.